Okay, this video is brought to you by Boolean.work. Be sure you guys go check out the website because they have so many interesting math questions that you guys will like. I really like Boolean.work because they focus on problem solving and their questions are really creative and challenging. You guys will like them too. Okay, as we all know, when we have 1/2 to the 1/2 power, this is actually equal to 1/4 to the 1/4 power. Well, how can you see it? You can just raise both sides to the 4th power and you'll see that this right here is pretty much 1/2 raised to the 2nd power, and then on the right hand side you get 1/4 to the 1st power, and 1/4 is equal to 1/4. Now this gives us a really interesting question. Can we find out more pairs of x and y so that x to the x power is equal to y to the y's power? Well, I have done a video that's really similar to this. X to the y is equal to y to the x. You guys can go check that out. In this video, I will use the same strategy and I will also use the Lambert W function. So I will do it by 2 ways. Right, so here are the conditions. I just want x and y to be both positive because if you have negative values, they may be dangerous, right? And I also don't want boring solutions, so I will say x is not equal to y because otherwise it will be too boring. Here we go. Let's do it the first way, right? So first method is that I will just show you guys what we did last time. I will begin by letting y equal to, I need a parameter, I will just call that to be t times x. Because you can assume that maybe y is just a multiple of x, just like this. Well, 1/4 and 1/2, right? Maybe just like a constant multiple. And starting from here, you can just put tx into y. So you will see that on the left hand side, we get x to the x power equals to tx for the y, for the base, and then raise that to the tx power like this. And your goal is to get x by itself in terms of t. Well, we both have the x power. So of course, we can just divide, well, technically I should do 1/x power on both sides, like this, so that this and that cancel, this and that cancel. And then you'll see that on the left hand side, I just get the x by itself. That's really nice. On the right hand side, this is t to the t's power, and then x to the t's power, like this. Well, let me bring this to the other side. So I'm looking at this as x to the 1st power over x to the t's power, and that's equal to t to the t's power. Well, by rule of exponents, this is the same as saying x to the 1 minus t's power, and that's equal to t raised to the t's power. What do we do next? Yes, we can just take both sides to 1/1 minus t's power like this, so that this and that will be gone. So we see that x is equal to, this is t raised to the t over 1 minus t's power, like that. That's very nice. Well, we know y is equal to t times x. We have x already in terms of t. Therefore, y will just be t times that x in terms of t. Namely, you can just put down t raised to the t over 1 minus t. And of course, you can just combine the exponents. You get y equals t raised to the 1 plus t over 1 minus t. And you can do some algebra right here. Get the common denominator, like 1 minus t over 1 minus t, and then 1 minus t plus t is just 1. So y is equal to t raised to the 1 only over the denominator 1 minus t, like this. So as you can see, x is equal to that, t raised to the t over 1 minus t's power, and y is equal to t raised to the 1/1 minus t's power. So this right here will be an answer to that, in the sense that you can just give me some legitimate t values, then we can generate good answers, okay? So that's pretty cool. And you can do some examples, but if you let t is equal to 5, just work that out on your own. Well, now let's do the Lambert W function. And our goal is to get y by itself, okay? To do so, let me first take the natural log on both sides. And of course, we can bring the powers to the front, so we get x times ln x. That's equal to y times ln y, like that. My goal is to get y by itself in terms of x. Look at, we have y times ln y, And remember, in order for us to use the Lambert W function, yes, a fish right here, and then times e raised to the same fish right here. And if that's the case, we get the fish back right here, okay? In order to achieve that, I will have to introduce the e somewhere. And I have the ln of y already here. The cool part is that if you look at this y as the following, let me bring down the ln y first right here. We just have to look at the y as e raised to the natural log of y. And you see ln y, they match. That's so cool. That's so excellent. That's wonderful. This is like a Christmas gift. On the left-hand side, we have x times ln x, like that. Well, what do we do? Now, I can just apply the w on both sides. So that you see on the left-hand side, it's just this. That's nice. And on the right-hand side, we get just the fish, which is the ln y. Let me put down this right here first. We have ln y equals the Lambert W function of x ln x, like this. And then I will just do e to this power and e to that power on both sides, so they cancel each other out. Finally, y is equal to e raised to the w of x times ln of x power, like that. Well, if you have this answer here, all you have to do is plug in some x value, work this out, and you can generate the y value, and the x and y value will satisfy this equation. All right? So these are the two ways that you can talk about the solution for that equation. And of course, if you have the parametric equations right here, you can graph it. And this is a Lambert W function. It's really cool. Let me know which method do you guys like better, right? Okay, so hopefully you guys all like this video, and before we go, I just want to tell you guys more about Boolean.work. I know many of you guys love math and you guys love to solve math questions, and Boolean.work is one of the best places for you guys to go get a lot of more interesting and challenging math questions, because they have the problems of which section. They have new questions every week, ranging from basic to advanced. You guys will love that. And they also offer courses in calculus, differential equation, number theory, probability, and interesting courses such as problem solving and like some math competition type of questions. Be sure you guys go check them out. Especially their courses are set up in an interesting and creative way. You guys won't get bored. I also go there myself to just get lesson ideas for you guys. And if you guys would like to sign up for the annual premium subscription, be sure you guys use the link Boolean.work/blackpenredpen. This way you guys can get a 20% off discount if you're one of the 200 people to sign up for the link. And at the end, I just want to tell you guys thank you so much for watching the video, and if you guys have any questions, just leave a comment down below and let me know. And as always, that's it.